welcome to another video. It's that time of the year again. It's Advent of Code and we're gonna have so much fun. I'm gonna try to get all the way to 25, but we'll see how many days I will actually handle. And usually when we have this kind of intro, I have some sponsor shots here. But this year, the sponsors that were reaching out was mostly AI companies that didn't really meet the actual seal of approval for me. They weren't really having a product that they could go to market with yet. So this year, as the creator economy is a little bit strange, I would much rather think that you should give some of your appreciation to an other creator. So I will put my donation link in the description, and I don't really care if you give me money. You can if you want, but I want you to pick out some creator that you watch regularly, that you really like what they do, and then give them a small donation saying, hey, I really appreciate what you do. So that is my call out for this year. Let's get into some Advent of Code. And day 4 of 12, printing department. You ride the escalator down to the printing department and they clearly are getting ready for Christmas. They have a lot of large rolls of paper everywhere and there's a massive printer in the corner to handle really big print jobs. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that. One of the elves replies when you ask for help. We're pretty sure that there's a cafeteria on the other side of the bank wall. If we could break through the wall, you'd be able to keep moving. It's too bad that all of the forklifts are busy moving those big rolls of papers around. If you can optimize the work of the forklifts are doing, maybe they could have the time to spare to break through the wall. The rolls of paper and at sign are arranged in a large grid, and the elves even have a helpful diagram, your puzzle input, indicating where everything is located, for example. The forklifts can only access roll paper if there are fewer than 4 rolls of paper in an 8 adjacent position. If you can figure out which rolls of paper the forklift can access, they can spend less time looking and more time down the hall to the cafeteria. In this example, there are 13 rolls of paper that can be accessed by the forklift, marked by X. Consider the complete diagram of paper roll locations. How many rolls of paper can be accessed by the forklift? I understand. I'm probably a little bit tired this morning. So we can only access rolls of paper if there is less than 4 papers in 8 adjacent positions. So we need to create a map, and that map needs to contain everything, and we then can check all the adjacent positions. So that's what we are doing. So first off, let's give ourselves a little bit more room here. We want to create a byte array. It could be an int array also, because it's or even a Boolean array. Now we are saving space here. So this is our map, new Boolean, like that. For each string line in lines, we do this, and we will say that we have lines size, so that's the size we have there, and then we have a bunch of these. And so first off, we will take map and start at 0. So I is equal to new boolean line length, and then we would do for this line like this, split on everything, so we get every character, and if s equals this @ sign, then we will do map I j equals to true, can also do ij false up here, we do 0 and j++. So now we should have a map with ones and zeros. And then we pretty much need to do it for y equals to 0, y less than map, or do we do x? No, y is the first one. Map length y plus, and I think we pretty much need to do could do like this. Height equals to lines size, and width could be equal to lines get 0. Now we need to also remember to switch over to day 4 length. So there we could have that, and so here we're width, and here we have height. So then we can use height, width. And we can do the, we simplify the map even more. Let's do that. Like that. We don't need to create those. We don't even need to create those. Only need to increase 1. Like that. And we can even simplify this even more. Now we are really thinking of minimizing code here. As I said, I'm a little bit tired this morning. So here we go. Let's do like this. And we will have a count here. Integers should be fine. Count plus equals, and we check movable, could say that, and we do x and y like that, and then we do count and we print it out. So when is it movable? Well, we are looking at the 8 adjacent places. So first off, if x, this map y times width, we can add width to it as well, like that. place. Width, y times width plus x, if that is set, which means that we actually have a value. Otherwise, if it's not set, we can return 0. We do that quickly. And then we will have another counter here. It starts at 0. And we need to check all 8 directions. So map, and we will have this again, and we do +1. If that, then 1 else 0. And now we need just a bunch of these. So we need one that is -1. We need +-1 with also a changed y coordinate, like this. And we are back. So here we do it with y plus, and we also need to do it with y minus, of course, like that. And here we have +- in the x direction, and then x will stay standard, and we do +- here as well, just to get the south and north directions as well. And if we return count less than, what did we say, 4? Fewer than 4, yes, less than 4, like that. In that case we have 1, otherwise we have 0. So we will return 1 extra and add to our count in one case. And we could do like this: if movable, 1 else 0. And so this movable will return a boolean instead. Could be more readable to say if it's true or false, and then we do the actual operation up there. I think that is better. So let's see, we will run this, and we will get an out of bounds here. So let's see, we can run the other one, see if we get out of bounds there as well. Index out of bounds. Let's see, width times height. Let's debug this. Let's see. We have 10 lines with 10, 10. So down here we should have 100, yes, values. Yes, of course, of course. We have all those edge cases as well. So if this, then count plus plus. But here, in this case, x needs to be less than width. Width -1. So we need height as well. Just for bound checking. So that's the first if statement. The second if statement, when we're doing minus, the x value needs to be larger than 0. I believe I've done this before in another. We have done those two in another of my projects here. Let's just do this all the way. So now x needs to be smaller than the width, but we also need it to be y less than height -1. And here we need it to be y larger than 0. For the minus case. Oh, we need another plus case. My bad. It's just x value we changed here to -1. And then we will do both of these again, but we will change the y value to be larger than 0. Here we need to be smaller, larger than 0. Here we do minus. And here we only need one of these and one of these. So we can remove the first statement here. It's not important. So here we need to do minus and plus. Now I think I have encountered all of them. And then we get 13. And 13 rolls of paper was the answer. So let's try it with the real score here. We get a much larger number. Let's try that. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So this was the first part. And we can go through that a little bit. So in this case, we have a map where we go through each of the iterations. First off, we create a map here with a bunch of booleans. Then we will go through each of the values. So we check each of the different positions in x, y coordinates and see if this coordinate is movable. And if that's the case, we will add to our count, otherwise we will not. And then we will print that out. And the movable case It's a little bit long here, but in pretty much the thing we are checking if we have something in the east position, in the west position, in the it's the north east, northwest, and then we have southeast, southwest, and then we have the north and south positions we will check. And if we have anything in any of those, we will add to the count, and as long as it's less than 4, it's truthable. So that's what our little exercise is checking. And we also have a check in the beginning here that we actually are standing on a position where we have an at sign. So that was the first day, or the first part of this day. Now the elves just needs to help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklift might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they keep repeating this process? Start with the same example as above. Here is one way you could remove as many rolls of paper as possible using the highlighted at sign to indicate that the rolls of paper is about to removed, and using X as an indicating that the rolls of paper is just removed. So first 13 rolls of paper, remove 13, and then they remove 12, then they remove 7, and then they remove 5, and then 2, 1, 1, 1, 1. Stop once no more rolls of paper are accessible by the forklift. In this example, a total of 43 rolls of paper can be removed. Starting with your original diagram, how many rolls of paper in total can be removed by the elves and their forklifts? So I think we can just keep this algorithm as is. And we pretty much do a while loop here. While moved, like that. And if moved equal to count larger than 1. And then we do a boolean. Moved equals to false, or true, because we are starting, and we need to be larger than 0. And then we will do an long sum equals to 0. And here we will do sum equals to, or plus equal to count. And then we do sum down here. So if we do true with our test case again, let's see, it will run for a while, and hopefully it will, no. Let's see. We need also, we need to run through this, and when we have figured out that these are movable, we need to remove them. So we will need another map here. Movable. And we will do arrays fill movable with false. So now we will set everything to false. And we can use this function again here. If movable count plus plus. And here we also will do movable width times y plus x. True. Movable map. Just like that. And then we will have another where we will check this movable map, and then we will take map with the same coordinate equal to false, so we will remove things then. So if we run that, we get 43, and that's the actual response for this one. Let's do the full one, and we get 8,587. Let's put that in. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So what did we do in part B then? Well, we already had our movable function down here where it checked if something is movable. We haven't changed that. We are just changing the logic around it. So first we have the map here with the width and height, and then we have a movable map so we can keep track on which things we can remove for each iteration. Then we will say we will want to sum everything up, and we also want a boolean to see, have we moved anything this round? And while we have moved anything, we will continue, and then we will do this fill of the map. We will fill the map with just falsy value. So a movable map, what we can move, we empty it out. And then we will do a count here and go through. And the only thing we will do, check, is it movable? We will mark it on the map, and then we will count up. That's the first loop. The second loop is check what we can remove, and then remove that from the original map. And then we will check, have we had more than 0 changes this time? Then we will set our boolean moved to true, and we will also add to our sum. And this will iterate until this moved value is false, and in that case we haven't moved anything this iteration, and we will print out the sum. So that was day 4 of Advent of Code. I hope that you learned something today. I hope that you liked this video. If you have any comments or suggestions, leave those in the comment section down below. If you haven't subscribed yet, please do that. And I hope we'll see you in the next video.